Hey guys, in this video I'm going to do this statistics and probability problem. We are given a continuous function PDF and we're asked to find the method of moments estimator for theta, which is theta tilde, and from that we're supposed to find out whether the estimator is unbiased or biased. So for these types of method of moments problems, sometimes you're asked to find a moment specifically using something like x squared, for example, in which case you probably want to use the second moment. But in this particular problem, we're not asked to find any particular moment, so we can just use the first moment. And for these types of problems, we're basically going to have that the sample mean is equal to the expected value. So we're going to find the expected value of x given our PDF, which we're also going to say is the population. Once we get the expected value, this is going to be equal to whatever. And from the right-hand side, we're going to solve for theta. And this is going to be our method of moments estimator. So we're going to have something with the sample mean on the left-hand side and theta tilde on the right-hand side, and that's our estimator. And then for the second part, we take the expected value of this, and if it equals just theta at the end, then it's unbiased. So let's go ahead and do the problem. So the first thing we need to find is the expected value of x. So the expected value of x is going to be from 0 to theta, which we're given x times the PDF. So we're just doing the first moment. So it's just e to the x. So the PDF is a theta to the a, xa minus 1. So that's equal to 0 to theta xa times a over theta over a. When we integrate that, that's going to be xa plus 1 over a plus 1 times a over theta a. And this is from 0 to theta. Plugging in theta gives us theta to the a plus 1 times a over a plus 1 times theta a. We can cancel out a theta a, which gives us theta a over a plus 1. So in this case, we want to think of this in terms of the sample. So we're going to say that the sample mean is equal to the expected value, which we got equal to this. And if we consider this the estimator, then we're going to solve for that. And that's going to give us a plus 1 times the sample mean over a, and that's our method of moments estimator for theta. The second part of the problem asks whether it's biased or unbiased, and if it's biased, whether it overestimates or underestimates. So we're going to do the expected value of theta, and something is unbiased if the expected value of the estimate is equal to the population parameter. So this would be unbiased if it's true. So that's going to be the expected value of this left-hand side. So that's a plus 1 times the sample mean over a. We can pull out a plus 1 over a because those are constants. This is equal to mu, which we have from the first part, which is just this expected value. So that's going to be a theta over a plus 1. A plus 1 and a cancel. So we have that the expected value of theta tilde goes to theta, or is equal to theta. So in this case, theta tilde is unbiased. And we are done with this problem.